Hello again. Today we are going to be learning about polynomials and linear factors. This is section 6.2 in your book. And I just want to remind you about factor trees real quick. We have the number 10, and you can factor, as you remember, a factor tree goes something like this, and each branch of the factor tree is basically a factor of the number. So we know the factors of 5, for example, are 5 and 2. And so we say that 5 is a factor of 10, 2 is a factor of 10, because 5 times 2 is 10. In a similar fashion, we can have a polynomial like x squared plus 2x minus 3. And we can also factor that, and we've learned how to do that in previous lessons. So real quick here, I can make this 1, 1, 3 times 1, and 3 minus 1 equals 2. And this is our factoring technique that we've been using. So we know that we can put here x plus 3 and x minus 1. And in a similar fashion to the factor tree over here, each branch here is being multiplied by each other. So we know that x plus 3 is a factor of x squared plus 2x minus 3, and x minus 1 is also a factor of x squared plus 2x minus 3. This has huge implications for us in the next section. For example, we know that 10 is said to be divisible by 5. 5 goes into 10 twice, and 2 goes into 10 5 times. That relationship also exists here. In the next section, we'll be doing some division, and it is true that if we take this polynomial and divide it by x plus 3, we will in fact get x minus 1, and vice versa. We don't have to worry about that too much right now, but just want you to understand how these factors work. These are called linear factors, and then of course, that is one of the lessons for today. So, we're going to be working with this stuff. So our first example in today's lesson is writing the expression. Here's a polynomial as a polynomial in standard form. This is factor form currently. It's totally factored. And we want to write it in standard form. That requires us to do a lot of FOILing. So we're going to start with 2 factors at a time. That has 3 factors, by the way. So we're going to take the x minus 3 and the x plus 4, and we're going to FOIL it. And so x times x is x squared. That's first times first. Outside times outside is going to be 4x. The inside is going to be negative 3x. And our last times last is negative 3 times positive 4 is negative 12. We can combine our like terms here, and we get x squared plus x minus 12. That is the multiplied version of the first 2 factors, but we have one more factor to go. So we now have to multiply this by our remaining factor here, which is x plus 1. So literally what that means is you want to take x times x squared plus x minus 12, and you also want to take the positive 1 times x squared plus x minus 12. Okay, so here we're going to have x times x squared is x cubed, x times x is x squared, x times negative 12 is negative 12x, and then we move on to this side, and we've got 1 times x squared is x squared, 1 times x is x, 1 times negative 12 is negative 12, and now we can combine all of our like terms and get our final answer. We have one x cubed term. We have a positive x squared and a positive x squared, so that's 2x squareds. And then we have a negative 12x and a positive x, that's going to be negative 11x. And lastly, we have our constant term minus 12. So now we have basically taken this function and we have written it in standard form. And that is one of the things that you're going to be asked to do. So in your homework, I would like for you, oops, too far there. In your homework, I'm going to give you a problem to do. So I'm going to write it up here in red. And it's going to be the same exact process, but you're going to have the factors of x plus 1, x plus 1, and x plus 2. So in your notes to be confirmed with on Wednesday, you're going to want to FOIL that all out like we did here and write it in standard form in your notes, and then we'll check it in class. So that's the first example that you have to do. The next example is to take a polynomial function which is in standard form and go the other direction. Now we want to write it in factor form. So we actually want to factor this out. First of all, this is doesn't appear to be a quadratic, but it has a trinomial. And every single one of these factors has a 2 in common. 10 divided by 2 is 5, 12 divided by 2 is 6. So we're going to factor out a 2 and an x, and that will leave us with x plus 5x plus 12. Sorry, that should have been x squared. X times x squared is x cubed, x times x, x squared, and then x times 12, 12x. So that is our first part. You'll notice that now what's remaining here is in fact a quadratic, so that we can continue to factor the way we have in the past. The factors of 12 are 6 and 2, but that's going to give you 4, not a 5. So we want to do, let's see here. Did I do something wrong there? I think I did. Hold up, hold up. Don't get scared. I did do something wrong here. I should have made this a 6. So we will put here 2x times a 6. Sorry about that. There we go. Now this will work. So when I factor it, I will get 1 and 1. And the factors of 6 are 6 and 1. And then 6 minus 1 will give us a 5. And that won't work either. Sorry about that again. Don't hate me. It's been a long day already. Okay. Our factors are going to be 2 and 3. Yay, finally third time's a charm. 3 plus 2 is 5. That is our factorization. So finally we can write this as 2x multiplied by x plus 2 and then by x plus 3. And there is our factored form. So again, I'm going to give you an example to try. And again, I'm going to put it in red here. So 3x cubed minus 3x squared minus 36x. Okay? That's going to be an example for you to do in your notes and to check it in class, next class period. Okay, the next thing we're going to do is we are going to talk about relative max and mins and zeros. Okay, so here's a little diagram for you. This is a cubic function. It doesn't have to be a cubic function, but this is a cubic function. And I just want to show you what a relative max and min is. A max is basically the highest point on the graph within a certain area. In other words, we understand that this graph is going to continue to go up, 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 up. That's what the arrow indicates. This arrow indicates it's going to go down, down, down. So if I were to ask you what is the highest point on the graph, there really isn't a highest point because it's going to go higher and higher and higher and higher and higher, and it's never going to stop. And if I asked you what the lowest point on the graph was, there really wouldn't be one because, again, it's going to go down, 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 down forever, and it's never going to be the lowest. However, we're talking about relative min and relative max, which is kind of another way of saying local max and local min. So it means that even though this graph is going to go on forever and it's going to get really high, in this region, in this local area, what is the highest point? There's the highest point. In this local area, what is the lowest point? This is the lowest point. Even though it's not the lowest overall, in this particular area, it is the lowest. So basically, we call those relative maxes and mins. Another word you could use is hills and valleys. This is like a valley here, this is a hill here. And so we're going to be showing you how to find those values on the calculator in a few seconds. Also want to point out these are the x-intercepts. The calculator calls them zeros. You have to get comfortable with that term. And the reason why they do that is because in a function, if you make y equals 0, it's the x-intercept. And so that's why we call these zeros. So that being said, we are going to do number 13 in your textbook right now. You can pause the screen and you can write all these steps down, but we are going to go through them as I do this example number 13 in your textbook. So pause the screen now because I'm going to continue. So number 13 in your textbook is f of x equals x cubed plus 4x squared minus 5x. And they are asking us to find the relative max, relative min, and the zeros of the function. So we're going to do that on the calculator right now. I am going to turn this light off so you can see the screen better. Hopefully I'm not totally darkened out now, but there is your calculator screen. We're going to go to our calculator, turn it on. Has a lot of stuff in there from yesterday, so I'm just going to go to my memory and reset it, because that's easier for me to do. So when I go to my y equals, everything's cleared out of the calculator's memory. So we're going to type in the equation. It was x cubed plus 4x squared minus 5x. And then we're going to graph it. Because I cleared the calculator's memory, the graph is going back to a normal 10 by 10 window. The first thing that you can see in the graph is that here it appears to be a valley, and the hill is over here somewhere. You can see it kind of goes off the screen. So one of the first things you want to do that's in your notes and in your calculator steps is to make sure that your graph, that you adjust your window so that you can actually see the max and mins in your diagram. So right now it appears that I need to adjust my window so that the y values are higher because it's not letting me see the graph. So I'm going to go to 20 and see what happens. It got better, but as you can see, it's still not there. So I need to go to my window again, and maybe this time I will try a y max of 30. And now I can see both the hill and the valley in my window. That's one of the first things you want to be able to do. Now I will go second trace, as your calculator steps indicates, and I'm going to find the zeros first. That is option 2. And you will notice that it asks a bunch of questions about the zeros. First of all, we said earlier that these are x-intercepts. So there are 1, 2, 3 x-intercepts in this case. So I'm going to go to the farthest left one. And I'm going to keep using my arrows to keep moving the cursor to the left of where I think it is. And I hit enter. And you will notice an arrow up here indicating that it's to the left of the point. And then I will use my right arrow because it says right bound now. And I will move the cursor to the right, hit enter. And now you will see these 2 arrows up here that are indicating that they will look for the 0 in between those 2 values. So I hit enter again to guess. And it's telling me that my 0 is -5. X equals -5 right here in the bottom corner. I'm not sure if that's clear there. It's a little blurry there. So let's do that. So my 0 is -5. So I'm going to go to my board, and we know that x equals -5 is one of my zeros, but it's not the only one. So I'm going to find the other one by doing it again. Second trace, option number 2. This time I want the left. I'm going to look for this 0 here. So I want to be to the left. This is to the left. Hit enter. I want to be to the right. But I don't want to go too far. Hit enter. So now you can, again, you'll see the 2 arrows up here indicating that they're going to find the value in between. I hit yes. And now I have 0, 0. So now I have another 0 to add. X equals 0 is another one of my zeros, another one of my x-intercepts. And then do it one more time. And I will go to the left. And I will go to the right. Hit enter. And my third 0 appears to be 1. X equals 1, 0. And that is how you find your zeros. So I have all of my zeros now. The other thing that this question asked for was my max and my min. So done the same way, you go second trace. This time for my minimum, I'm going to choose option 3. And again, it takes me through this questions of left bound, right bound. This is my minimum value right here. So I want the cursor to be blinking to the left, hit enter, move it so it's blinking to the right, hit enter, enter, and my minimum is this weird decimal here, 0.522 is the x value. They typically want the y value. When they're asking for the minimum, they want the y value. So my minimum is going to be x is 0.522 and the y value is negative 1.378. That's my min. Do the exact same thing and we will get our maximum second trace. This time option 4 for maximum. And you can see our maximum is up here. So we are going to move our cursor till it's blinking to the left, hit enter, move it till it's blinking to the right, hit enter, enter again to confirm, and we have negative 3.189. And our y value is 24.193. And that is how you find max and min using the calculator for your homework. So now we will go back to our other screen here and continue with the examples for that. I will turn these lights back on. Example 4. Example 4 asks us to find the zeros of the function, and this is actually very easy to do when it's in factored form. You'll remember that earlier we took something that was in standard form and put it into factored form. Well, this is already in factored form. Here's my function y equals, and we're going to use the zero product property to find the zeros. It's very simple. When you find the zeros, like I said earlier, it's basically asking you to find the x-intercept, and you find the x-intercept by making y equals 0. Here's your y. So you're going to make it equal 0. So I'm going to say 0 equals x minus 1, x plus 9, and x plus 2. And like before when we had quadratics and we were solving quadratic equations and we only had 2 factors equal to 0, that means that any one of these factors could be equal to 0. So x minus 1 equals 0, x plus 9 equals 0, x plus 2 equals 0. And we solve it that way. So in this case, I add 1 to both sides, and my answer is x equals 1. In this case, I subtract 9, and x equals negative 9. In this case, I subtract 2, and x equals negative 2. So my 3 zeros are 1, negative 9, and negative 2. It's that simple. We're using the zero product property there. If x is 1, then 1 minus 1 would be 0, and this entire thing would be 0. So that's basically asking us for the x-intercepts. In your notes, I'm going to need you to do one of these yourself. And so here is the example that I want you to do. Again in red, y equals x minus 7, x minus 5, and x minus 3. An example for you to do, again, find the zeros of the function. Here we have another application of polynomial functions and this whole standard form thing is, in this example, they're asking me to write a polynomial function in standard form with the following zeros. So basically what they're asking me to do is to go backwards. We just did an example where it was in factored form and then we found the zeros. So this time we know what the zeros are and we're going to work backwards. So what you want to do is you want to say that x equals negative 3, x equals negative 5, and then x equals 1. And then you go backwards. I want to write this as a factor, so I would then add the 3 to the other side, making it x plus 3 equals 0. I would add the 5 to the other side, making it x plus 5 equals 0. And I would subtract the 1 to the other side, making it x minus 1 equals 0. And because they're all equal to 0, I would then make them a product, x plus 3 times x plus 5 times x minus 1 equal to 0. Okay? And then lastly, we would have to actually, because they want this in standard form, not factored form, we can't leave it like this. We now have to FOIL it all. And we did that earlier at the beginning of the class period. So we want to FOIL this all. I'm going to do it really quick here. X times x is x squared. X times 5 is 5x. X times 3 is 3x. And then last times last is 3 times 5 is 15. Okay, so then that's going to give us x squared plus 8x plus 15. And then we have to multiply that by x minus 1. Okay, so x times x squared is going to give me x cubed. X times 8x is 8x squared. X times 15 is 15x. And then we're going to go negative 1 times x squared is negative x squared. Negative 1 times 8x is negative 8x. And negative 1 times 15 is negative 15. Combine all those, and I get x cubed. 8 minus 1 is 7x squared. 15 minus 8 is 7x and minus 15. And this is now my polynomial function in standard form with those given zeros. Again, I'm going to want you to do one of these. And again in red, I want you to do, the zeros are going to be negative 4, negative 2, and 1. All right? And then we're going to have, this last example down here is the same thing. I'm not going to do the entire problem. I just wanted to show you what could happen when you have a 0. That kind of throws people off sometimes. So I want to make sure that I talk about that real quick. I'm not going to do the entire process. But basically the same thing is true. You would have x plus 3 as a factor. And you would have x minus 5 as a factor. And when you have a 0, it means that you're going to have x by itself as a factor. So here we had a plus 3 because it was a minus 3. You had a negative 5, so that was a positive 5. You had a positive 1, that was a negative 1. When you have a 0, you just have x by itself. And then you multiply it all out and you get the same kind of process going on there. Okay, so I want you to do 2 examples here. The first one is negative 4, negative 2, and 1. And the second example I want you to do is very much like it, but it's negative 4, negative 2, and 0. Both of these examples need to be done in your notes for the next class period. Okay, so then we have the last thing in this lesson, and that is multiplicity. Multiplicity is basically when you factor something and you get the same factor more than once. So here I have a factor of x plus 3, here I have an x minus 1, but because it's squared, it means that this factor is happening twice. It means that this factor is happening 3 times. So multiplicity, that's what that means. Okay, so for multiplicity, we're going to say here, the example here says, for each function, find any multiple zeros and state the multiplicity. So the multiple zeros are going to be this guy, and this guy. Okay? This is a 0 or a factor, but it doesn't have any multiplicity. It's like to the 1 power. So when it says to find the multiple zeros, it's going to be x minus 1 equals 0. So x is going to equal 1. And all you have to say is that it has a multiplicity of 2. That's it. This guy is going to be x equals negative 2. And because it's to the 3rd power, it has a multiplicity of 3. Okay? And this guy is x equals negative 3, but it has no multiplicity because it's only there once. Okay? And in this case, in part B, we are going to have to factor it first because to find the zeros, you have to factor it first. Since they all have an x in common, you factor out the x. And then we're going to use this little factoring technique for this portion because it's a quadratic. And 9 is going to be 3 times 3, and 3 plus 3 is 6. So you'll see that you get the same factor twice, x plus 3. We can write that as x plus 3 squared. So that means that our multiplicity is going to be x equals negative 3, that's our 0, and it has a multiplicity of 2. This is x equals 0, but again it has no multiplicity because it's not squared or cubed or anything. All right, so that takes care of multiplicity. So one last thing that you have to have in your notes is this guy. Equivalent statements about polynomials. These 4 things here, they're all the same thing. So I am going to show you that all this is basically different stages in the process. So we have this polynomial, okay, in standard form. I can make it factor form by using my little plus guy. We already factored this one earlier, so this is 3 times 2. And if I go -3 plus 2, I'm going to get -1. So in factor form, this would be x minus 3, x plus 2. That would be the factored form. And we said earlier that if it's factored, it means that x minus 3 and x plus 2 are factors of x squared minus x minus 6. That's the first statement. These are all equivalent statements. They all mean the same thing. They're just different forms in the process. So number 2, x-intercepts. We talked about that. If you make y equals 0, then you're going to get that x equals 3 and that x equals -2. If you make y equals 0 and you solve, you're going to get x equals 3 and x equals -2. So as the x-intercept, you would put x is 3, y is 0. X is -2, y is 0. So the second statement says 3, 0 and -2, are the x-intercepts. Statement 3 is that x equals 3 and x equals 2 are solutions. Another way of calling that is this is the solution to my problem. Number 4 is x equals 3 and x equals 2 are zeros. So saying something is a 0, saying it's a solution, saying it's the x-intercept, they're all the same thing. They're just written in different ways. So you have to keep that in mind. Make sure that this is in your notes as well, because it's going to come in handy in the future. And that covers today's lesson.